Hello, grade 11 learners. This is teacher Jessa and welcome back to our discussion in general mathematics. We are now on quarter 1, week 2D with our learning competency. The learner represents a rational function through its table of value, graph, and equation. Now let us discuss the solutions to your enrichment activity. For our problem, it takes a total of 250 workdays to build a house for charity. For example, if 2 workers build a house, it takes them 125 actual construction days. If 10 workers are present, it takes them 25 construction days to build the house. Write a rational function that represents the number of construction days to build as a function of the number of workers. Also, provide its table of value, ordered pairs, and then graph the function. For our solution, let f of x be the function representing the number of workdays to build a house for charity, where x is the number of workers. Let us note that the total workdays to build the house is 250. Based on our given, if x is equal to 2, f of x is equal to 125. Or, if 2 workers build the house, it takes them 125 working days. If x is equal to 10, f of x is equal to 25. Or, if 10 workers build the house, it takes them 25 working days. If we try to relate it to the total workdays, which is 250, f of x is directly determined by dividing 250 total workdays into x or number of workers. Thus, our function f of x is equal to 250 divided by x. Using our function f of x equals 250 divided by x, let us now determine our ordered pairs. First, let us assign values for x or number of workers. So for our example, we will have x at 1, 2, 5, 10, and 25. Remember, you are allowed to assign any value for x, but be reminded that it must be a counting number. Okay, so for our solution, so we apply substitution. So if x is equal to 1, f of 1 is equal to 250 divided by 1, which is equal to 250. So for our ordered pair, we have here 1 and 250. If x is equal to 2, f of 2 is equal to 250 divided by 2, which is equal to 125. So for our ordered pair, we have here 2 and 125. If x equals 5, f of 5 is equal to 250 divided by 5, which is equal to 50. So for our ordered pair, we have here 5, 50. Next, if x is equal to 10, f of 10 is equal to 250 divided by 10 equals 25. So for our ordered pair, we have here 10, 25. And lastly, if x is equal to 25, f of 25 is equal to 250 divided by 25, which is equal to 10. So for our ordered pair, we have here 25, 10. So for the set of our ordered pairs, we have now here 1, 250, 2, 125, 5, 50, 10, 25, and 25, 10. Okay, now let us proceed to the table of values. So for the table of value, we simply write our ordered pairs in tabular form. So for our x coordinate, we have here 1, 2, 5, 10, and 25. Okay, we write it on the x column or x row rather. And for our f of x or value of y, we have here 250, 125, 50, 25, and 10. And we also write it on the f of x row, okay, aligning with their corresponding x values. Okay, now let us proceed to the graph. Okay, so for our graph, okay, so for our x-axis, we have here the number of workers, And for the y-axis, we have here the number of workdays. So in graphing, I use Graphmatica. Okay, and on this side, I have here our values for x and y. So we plot the points. So for 1 and 250, so we have here 1 and 250. Next, 2, 125, we have here 2, 125. Okay, next, 550 around here. Next, 10, 25. Okay, this one. And lastly is 25, 10. Okay, so as you observe, okay, as our x or number of workers become bigger, our y or number of workdays becomes smaller. Or in short, if there are more workers, the number of workdays becomes smaller. Now let us proceed to Qtr-1 Week 2E. With our learning competency, the learner finds the domain and range of a rational function. Exercise number 1. Find the domain of f of x equals 4 divided by x squared minus 4. So domain are the set of possible values for x or the input. So to find the domain, we determine all values of x that will make the function undefined. So when can we say that the function is undefined? That is simply when your denominator here is equal to 0. Take note, any number divided by 0 is undefined. So first step, simplify or factor the function or your denominator. So our denominator here, x squared minus 4, is factorable since it is difference of 2 squared. So this will become f of x equals 4 divided by the quantity x minus 2 times the quantity x plus 2. Okay, then determine the zeros of the denominator. So to do that, we equate our denominator to 0. So that becomes the quantity x minus 2 times the quantity x plus 2 equals 0. Then, we equate each factor to 0. So this becomes x minus 2 equals 0, x plus 2 equals 0. Okay, then solve for x. So in that case, we need to eliminate negative 2 here and positive 2 here on the other side. So to do that, we add the additive inverse of negative 2, which is positive 2 on both sides. Then we added negative 2, which is the additive inverse of positive 2 on both sides of this equation. So this will be eliminated. So the result now will become x equals 2 and x equals negative 2. So hence, the domain of the function is the set of all x except 2 and negative 2. In symbol, domain is equal to x such that x is an element of real number, x is not equal to 2, and x is not equal to negative 2. Okay, now, why do we exclude positive 2 and negative 2 for our solution in our domain? So we have here, okay, by substitution, so if x is 2, f of 2 is equal to 4 divided by 2 squared minus 4. F of 2 is equal to 4 divided by 4 minus 4, which will result to 4 divided by 0. And again, any number divided by 0 is undefined. So if x is negative 2, f of negative 2 will become 4 divided by negative 2 squared minus 4 equals 4 divided by 4 minus 4 equals 4 divided by 0, which is again undefined. Okay, that is why for our domain, we have our exemption. Okay, let us proceed to the range. Find the range of f of x equals 4 divided by x squared minus 4. So range are the set of possible values for y or the output. So to find the range, we follow the following steps. Okay, first, let f of x equals y, or simply change f of x to y. So this will become y is equal to 4 divided by x squared minus 4. Then apply cross multiplication. Okay, so in this case, since y here has an imaginary denominator of 1. Okay, so we simply multiply our denominator, x squared minus 4, to y. Then copy 4. So that will become y times x squared minus 4 equals 4. Okay, next, distribute y. Then simplify. So this will become y times x squared, then y times negative 4 equals 4. Simplifying, x squared times y is equal to x squared y, and negative 4 times y is equal to negative 4y equals 4. Solve for x. So to solve for x, we see to it that the other side of our equation must be composed of terms having x variables. That is why we combine terms having x variables on the left side, and those terms without x variable will be transferred or moved to the right side. So in here, negative 4y does not have x variables, so we transpose it to the other side. So with that, negative 4y becomes positive 4y. So simply copy x squared y and 4. Okay, next, since we are solving for x, we need to make this side of our equation into x only. So that is why we multiplied both sides of the equation to 1 divided by y, which is the reciprocal of y, in order to eliminate y. So that becomes x squared equals 4 plus 4y divided by y. Okay, next. Okay, we still have here squared, so we get the square root of both of our equation. So square root of x squared is equal to square root of 4 plus 4y divided by y. And take note, square root of x squared is x. So we have here square root of 4 plus 4y equals y. So our radicand here is 4 plus 4y divided by y. So since we have here our denominator, which is y, we need to make sure that our denominator is not equal to 0. And since it is a square root, our radicand here must be positive. Okay, so for our range, y such that y is an element of real number and y is less than or equal to negative 1, union y is greater than 0. It means that 0 is not part of our range, as well as numbers which are greater than negative 1 is not part of our solution for our range. Okay, let us now proceed to your enrichment activity. Letter A, find the domain and range of f of x equals x divided by x minus 3. So for the domain, determine the 0 of your denominator. So your denominator here is x minus 3. So equate it to 0. That becomes x minus 3 equals 0. Then solve for x. So x is equal to 3. Hence, the domain of the function is the set of all x except 3. In symbol, d is equal to x such that x is an element of real number and x is not equal to 3. For your range, the first step is to change f of x to y. So this becomes y is equal to x divided by x minus 3. Then cross multiply. So we have here x minus 3 times y equals x. Then distribute y. So y times x equals xy. Y times negative 3 equals negative 3y equals x. Then solve for x. So in this case, we combined all terms having x's on the left side of our equation and those terms without x variable on the right side of our equation. That is why we move x here to the other side, which becomes negative x, and we also move negative 3y to the other side, which becomes positive 3y. Okay, so we have here two terms having a common factor of x. So we factored out x. So xy divided by x becomes y, and negative x divided by x becomes negative 1 equals 3y. Okay, then we need to eliminate y minus 1. So we divided both sides of our equation to y minus 1. Then cancelled out y minus 1. So this becomes x equals 3y divided by y minus 1. So next is to determine the zero of our denominator. So just like we did with the domain, so we have here our denominator y minus 1 equals 0. So what value of y will make the denominator 0? So that is equal to 1. So 1 minus 1 is equal to 0. So for our range, that is y such that y is an element of real number and y is not equal to 1 or except 1. Okay, letter B. Find the domain and range of f of x equals x minus 5 divided by x plus 3. So for our domain, again, determine the zero of our denominator. So equate x plus 3 equals 0. So that is x plus 3 equals 0. Then solving for x is equal to negative 3. Okay, hence the domain of the function is the set of all x except negative 3. So in symbol, that is x such that x is an element of real number, x is not equal to negative 3. So for our range, okay, we change f of x to y. So that is y is equal to x minus 5 divided by x plus 3. Then multiply your denominator here, x plus 3 to y. So that becomes y times x plus 3 equals x minus 5. Distribute y. So this will become y times x, xy, y times 3, positive 3y, then copy x minus 5. Solve for x. So again, combine all terms having x variables on the left side and all terms without x variable on the right side of our equation. So positive x here, okay, was moved to the left side, becomes negative x. Positive 3y moved to the right side becomes negative 3y. And we simply copy xy here and negative 5. Okay, so again, these two terms have a common factor of x. So this will become x times y minus 1 equals negative 3y minus 5. Okay, divide both sides of our equation to y minus 1 to eliminate y minus 1. Okay, so this will become x is equal to negative 3y minus 5 divided by y minus 1. So again, determine the zero of our denominator. So what value of y will make y minus 1 equal 0? So that is still 1. 1 minus 1 is 0. So hence, the range of the function is y such that y is an element of real number and y is not equal to positive 1. For letter C, find the domain and range of f of x equals 2 divided by x squared. So for our domain, determine the zero of your denominator. So we have here x squared equals 0. So that is x equals 0. X is equal to square root of 0. So x is equal to 0. So that will be the exemption for your domain. So domain, set of all x except 0. So in symbol, x such that x element of real number, x is not equal to 0. For your range, so we have here change f of x to y is equal to 2 divided by x squared. Then cross multiply. So this will become y times x squared equals 2. Okay, distribute y. So that is y times x squared is equal to x squared y equals 2. Okay, then solve for x. So in this case, we divide both sides of the equation to y to eliminate y. Okay, then this will become x squared equals 2 divided by y. And since we have here squared, we get the square root of both sides. So we have here square root of x squared equals square root of 2y. So for the square root of x squared, we have x is equal to square root of 2y. So since we have here again a radical symbol, so our radicand here must be positive since it is square root. Because if this radicand will be negative, that will be an imaginary number. But then again, our y here is on the denominator side, so which means y must not be equal to 0. So what are the numbers in which will make our radicand here a positive number and wherein it will not be undefined? So that is, okay, y such that y is an element of real number and your y is greater than 1. Which means the number that will only belong to your range are numbers which are greater than 1, such as 2, 3, 4, 5, 6, and so on. Okay, thank you so much for listening and see you again next time.
If you are not yet a subscriber of my channel, kindly subscribe and please don't forget to like and share. And if you are a subscriber, you will be updated with more uploads for these learning activity videos. Thank you and always stay happy, healthy, and safe.